So I start the recording. So we're going back to Python after some pause in between where we're discussing about mathematics. So where we left, basically we're discussing about functions. So we discussed a lot about Python, and I said the basic Python or the basic programming language. So that contains some basic structures that we started with, what data types are, then we said what operation can be done, and then we said different, we basically discussed control flow and these sort of things. So basically all of these things were what makes a programming language a programming language. Now what we are doing is we're basically learning how to write an efficient code. So without even functions you can write the code. Okay, but we said this code, if it goes to large scale and then you'll be working in a corporation or probably you'll be working with some set of people, they'll have to understand your code. So that for better code readability, code reusability, and all these things, okay, better style of the code, we use these additional features. So we were in the functions. I think we have discussed a lot about functions. So just let me revise what I meant by functions was like this. So I said consider this as a function. This is a machine. Something goes in, something comes out. Okay, so this is what we called as input, and this is what was our output. This is what we saw a function if it's a black box. So let's suppose you can think a function like a machine, which let's suppose we'll take this as oven, some microwave oven. You give some input to it and it gives some output. Similar is the function of the functions. So they basically take some input and give you some output. And we discussed a lot of things about what inputs are. They're called parameters, and then we said what are different types of these parameters, and then we have take output also. Okay, now today we'll discuss about this output. Okay, because we have done discussing about input and how to basically unpack those arguments. We have discussed a lot about this input. So today we'll start with the output. So how to take output from the function? So let me just clarify one thing. So let's suppose we are doing something in a program, because program has different blocks. So here, let's call this function f1. This is function f1, and right here, this is function f2, and this is function f3. Let's suppose this function f3 calls f2 and this calls f1. Okay. So what I said is there is a stack that's called calling stack. So when you call these functions, there's a stack formed. So let's suppose program starts with some main function. This is the main, and main starts its calling from, let's suppose, f3. So what will happen is in this calling stack, main will be pushed first. Okay. So once main is pushed and then we run the main and it sees that it calls f3, then we'll go to f3. So main will be in the stack and then we'll call f3. F3 will get what's called as, we'll push it in the stack. So there will be two terms in the stack, push and pop. By push I mean we'll insert something in the stack, and by pop I mean I'll evict that element. So this is called as call stack. Stack is a type of memory. Stack is a data structure. I think most of you might know that. Okay, so once we start our execution from the main program, so the first thing that happens is main will be loaded into this call stack. And when we saw that main basically called this f3 and then f3 was pushed. Once this f3 was pushed, then we saw that internally this f3, it calls f2, then f2 will be pushed. Okay, and once this f2 is pushed, when we went to the code of f2, you saw that f1 is called there. So what will happen here is f1 will also be pushed. Okay, so when will these things be popped out? When will be they evicted? When we are done with the functionality, when we are done with whatever code has been written in function f1 or something like that. So to evict, there is a way. Okay, so there is a way that statement is called a return statement. So return, basically what it does is, the return statement is a fundamental part of that function. So it serves to send the output to the caller. Okay, so here main called this f3. So once f3 will be done with its functionality, so it has to probably return some results, or it may do nothing also. Okay, it may return some results, it may do nothing. So in order to return the results, we use this return statement in order to give that output to the caller, and this function is called caller. Okay, main is the caller of f3. F3 is the caller of f2. F2 is the caller of f1, and f1 calls no function. Let's suppose f1 has some simple basic statements. So the first statement that we will study is return. The first statement, but the only statement that basically by which we take the output. So what I said is, so this return statement, it serves it serves so that it can send the output to the caller function. So we have a caller function. We have a caller function which calls something. So when it calls, let's suppose here we had main called this f3, and it wants f3 to do something. Okay, and f3 does that thing, and in return it wants to get some output. Okay, let's suppose we are giving it a number. We are giving it a number, let's suppose x, and the function f3, it squares the number. Okay, if we give 4, it should give me 16. That 16, this thing should be now given back to the caller. So the function main basically called this f3. So for the main expects square of the number. So this is what the return value is. Okay, so that's the whole purpose of the return statement. Basically, return statement, it serves to provide the output of the function to the caller who have called it. Okay, so there are a lot of functionalities of this return statement. The first thing, it returns the values. So okay, I'll send you what are the functionalities. Functionalities of return. If you go back to on this caller, you saw I told you that once the function is complete, then only it will be evicted. So f1 will get evicted from here. So again the control will reach to f2, because now f2 was calling f1. Once f2 called f1, f1 did its job, and after that what happened is, and it will evict f1, and f2 will again continue start executing. Once f1 is done with its job, it will also return something to f3, because f3 is the caller of f2. Okay, and after that f3 will keep on executing. If there are some lines below it, there are code lines, and after that once it is done, it will also evict f3. So after that it will go back to the main. So main is the, basically the program where we started. So when we are done with the execution, then this main will also get evicted from the call stack. Okay, then the program execution will get completed. So for that, what I'm saying is, the first functionality that you saw is returning values. The first functionality is returning values. You can return values. Okay, so by values I mean these values can be of any data type. They can be numbers, they can be strings, they can be lists, they can be dictionaries, and sometimes also other functions also. Okay, that's specific to Python, but right now what I'm teaching you is art of programming. So the first thing is, I usually teach you the generic thing about these statements, and then we'll go into the Python, how Python has manipulated those things. Okay, in generic, so every programming language will give you some sort of return. So in that, that's the functionality which I am telling you right now. The first thing is, it will return values. Okay, per se in Python it can return different data types, and in also other languages. So data types in Python are numbers, strings, lists, dictionaries, so it can return those. So that's the first functionality. Second functionality is early exit. So you can exit these things early. Okay, let's first, I think we should go to the coding window and first deal with this return values, and then probably we'll see what early exit is. Okay, let's start with this. Give me a second so I set up the coding environment. So the first thing we'll see is how to basically return a value. Okay, let's suppose I'll write a simple function of adding two numbers. Okay, which we have been doing quite often. So what I'll write is, I'll write definition. So definition is the keyword that we use before calling a function. I'll call this add. I'll have two arguments, a comma b. So these are the two arguments which I'll take, and then what I'll do is, I'll just add these two numbers. What I can do is, I'll return a plus b. Okay, so this here, what it does is, it'll return the value. Usually we have a habit of printing things. So when we start as a beginner programmer, so we'll write a plus b. Okay, something like this. But this print does not mean you return the value. Okay, why do I mean, what do I mean by returning? By returning, I mean after that you can utilize the value somewhere. Okay, once you added that value, let's suppose you had two numbers, it's a big program, and you wanted to add these two numbers, and then you wanted to use the added thing together, and you wanted to use that sum of two numbers somewhere else in the program. Okay, usually what we do is, in order to check the functionality, we use to print. Okay, print will be just print on the screen, but what this return will do is, it'll give back to the caller. So let's suppose here I'll call this function. So this function is add, and I'll call this with 1 comma 3. Okay, just let's run the program. So if we run it, so here we have to write Python and test1.py. Okay, so if you see, it showed me this. Because of this print statement, it gave 4 on the output screen. But what I'm saying is, this print is just to display the values, it's not to return the values. The return basically is this. If I just comment this return, okay, if I just comment this return, so it'll again give me the same output. You saw the 4 on the screen, but what I want is, I basically want the value, I want to manipulate it somewhere else in the program. Maybe it's a complex program, and I'm just taking that a plus b value and doing something else to it. So what I can do is, if I write this return statement now, okay, so now that return, I can store it somewhere, because as you know, it's an integer. So what I can do is, I can store it somewhere. I can store it as sum. Okay, let's just call it su. Okay, this is now what I have done is, so this add calls this function. This calls this function def add a comma b. After that, what it returns me this a plus b, and then this line here, it stores that sum in this su. So if I just run this, nothing should get printed. Okay, here you see nothing got printed, but if I want to print that on the screen also, I can see print su. Now if I want to do something with it, okay, so after this I can just do this. So you saw the 4. So here if you see this SU now, this contains the return value that was returned by this function. Okay, that's what I meant by returning a value. So you can return, or let's suppose you can write in the function, you can just square a number if given a number. So I'll just make in the function. So as to clarify, so we can write definition square, and then I'll take a number a, or maybe better is to write num number, oops, number, and then I'll square it up. So what I can do is I'll write return, and then I'll write number. To square the number we can do this. Okay, number to the power 2 or number multiplied by number, that's also good thing. So here what we can do is we can just give a number and square it up. So let's give a number 25. If you want to square it, the answer should be 625. So if you run this, so here you got 625. So this is the one demonstration where I'm telling you that a return is used to return the values whatever function did, and you have to return those values, and you can store them somewhere. I store them in SU, and now I can do anything with SU. Let's say I can use this SU anywhere else. Okay, I can print SU plus 3, so it should be now 628. If I just add this, so now the answer is 628 because I got SU from calling this function, and then I can just add 3 to it. I can do something to it. Just adding 3, you can do much more than this. Adding 3 is just one use case. You can do a lot of things with these values now. Okay, I hope that this is clear now. Is there a question on this? Is there a question on returning values? Yes, yes. Yes, Muzaffar has a question, Fahad has a question. Yes, yes, Fahad, go ahead.
I have a question.
Mm-hmm.
I think it is out of scope, but what if I return a lambda function? How will the does the call stack somehow change when I pass lambda
I'll
function?
come to lambda functions probably in couple of minutes in the same lecture today, and we'll take the question that time.
Oh, okay.
Okay, yes, Muzaffar, you have a question.
Sir, can you show us the code, sir? Then I will, maybe it will be easier to ask a question.
Yes, yes, yes. Here is the code.
The last one, print SU plus 3.
Right,
If we store it in a variable, then
right.
it can be stored, right?
Yes, yes, it can be stored. Yes, yes.
So then it will act like same the return, right?
No, 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 no. So what I'm saying you right here is, so this is not a function call. So here if you see, if I do some arithmetics, let me go back to the code so that I can show it. So here you are saying that let's store this value also. Let's store a some value, let's suppose new. So we'll store this as su plus 3. So now you are doing a basic operation on it. Okay, functions are not this. Functions what you do is you do lot more than this. Because in functions you have a lot of code. You don't write just single line. So I just, for the sake of demonstration, I just wrote a single line. But in functions there can be hundreds of lines. Okay, so in order to execute that thing and then to return some value, that is what I mean by return. So here also in a way you can also say yes, it is somehow assigning the value. Okay, but here I'm not calling any function. I'm just using one value, that su, which takes some which gives a number 25 to this number square, and it gives 625 back, and then adding some 3. So this is just basic computation. So if you again have to make it a function, you can make, but functions generally do not have just a single line. Okay, functions will have more than one line usually. Am I clear?
Yeah, thank you.
Okay, let's go ahead now. Okay, so the first use if we see is return values, and then what I said is, I said second thing is why return can be used. You can use it to early exit. So what I mean by early exit, so let's suppose in your program you are writing a program in such way such that if some condition is met you want to do something, if something is met you want to do other thing, and sometimes you want to early stop, and if a certain condition is met you want to early stop, you want to stop the program, and it is usually used for, sometimes used for debugging. Okay, sometimes used for debugging also. If you want to early exit the thing, you don't want the program, if certain condition is met you just want to throw the error. So I'll say, I should say error handling rather. Okay, you don't want that error unnecessary, because you know that there is a case, if that thing is met I want to throw some error. Okay, or maybe what I can do is I can just stop the execution, I can just return the value. Okay, that's what I mean by early exit. By early exit I mean the full function is not necessary that I'll execute that. Okay, the return statement is used to early exit that function before it reaches the end of the function. Okay, it is useful when you want to basically handle certain conditions or scenarios without executing the rest of the code. So let's suppose you have a code like this. Okay, and as a condition is, let's suppose this is the definition of the function, something is met over here, and then you said the whole point is now it's better to not execute all of these lines, so it is better to just just stop the execution here. Let me give you an example. Let's suppose if you want to say see if a number is even or odd, okay? Because now there are two things. You have to see if it is even or else if it is odd. So what you can do is you can just write a thing so that it does not go into the else block, or it does not run the whole code, and it just returns something. I'll just give a basic example, and probably we can then go to the more advanced examples. Again, going back to the code window, so that, oops, give me a sec. So the first example that I showed, this example was, let's comment it out, and then, oops, we'll go to early exit. Early exit, and then I'll comment this up. So here I'll write a function. Let's suppose I'll write a function is a number even or odd. Just a basic example. So I'll say def, and I'll write is even. So I'll get a number as an input. Let's call this number. Okay, so what I can do is I can write if this number, oops, if the number that I'm getting as an input, if it is divisible by 2, okay, if it is 0, so I usually say if it is, then it is odd, let's say to do, okay, else it is, again write to do. So this is how we usually write the code. If you have to do something and you write like this. So what I'm saying over here is, if number is this, so what I'm doing is I have to return early exit. If I just met the first condition, it's better not to go in the second condition. So what I'm saying is I'll just return the value. I'll return something. So that I'll return true. So because this is checking is even, and I'm expecting the value to be boolean. So I'll say return true. Yes, the number is even. So otherwise what I can do is I can say return odd. Return odd, that means return false. Here you can see that it will early exit this. So return, what it does is it'll, if a certain condition is met, if the number is even, it will return it over. Otherwise it will go to this. Okay. So if I run this code, let's suppose I'll just call this is even function. So I'll call this is even, and then I'll call it the 4. So here you should not see anything on screen, but if I want to print something, so I can print this true or false. So I'll just print it. So if I just save this and then run the code, so here you can see true. 4 is even, that's true. Okay, it's a boolean value. So if I'm giving 5, so 5 should be false. That's false. So by early exit, I mean that if a certain condition is met. Let's suppose right now here we had some other conditions also. Okay, we had some other things. Let's say we don't have this else. Okay, we have this print hi, you did not early exit the function. So when will this execute? Okay, this is over here. So what I'm saying is, so if a number is even, then this will early exit the code, and this line won't be executed because it's after the return. Okay, otherwise what will happen is, so this code will only get executed if the number is odd. Let's suppose I'll write number 6 because it's even, so this will give me true value. So if I just run this code, so if I run it, so Python test demo, you saw true. But what I'm saying is, if I give some odd number, so this early exit won't happen. So what will happen is, so all these code lines which will be beneath this, so maybe what I'll do is I'll say print this and then return something else. I can also return after this. So I'll say return. Let's suppose what I can do is I can return something else. I can return, let's say false, or maybe I can return anything that I want. I can return a number itself also. Okay, what I'm saying is, here if the number is even, it will early exit, otherwise it won't early exit. If I just run this code, you can see, so the value was true because I gave, oops, I have to save it. So now if you see this, so the value was false. Okay, so this I have to print. Maybe I'll decrease the size. So here now if I see it, you can see the print hi, your function did not early exit. This is also what got print on the screen. So any questions on this early exit? I hope that I made the point clear. Any questions on this? Yes, we have a question. Yes, go on.
I have a question that if I encounter like when we early exit, this function is removed from the call stack and the value
Yes,
is
yes,
returned.
yes.
But when I encounter an error,
Mm-hmm.
what happens then when I encounter an error in a function?
Okay, it basically
Will,
trace back. It does the same thing. It'll keep on evicting. So if you have seen Python's errors, it'll show something called as trace back. So wherever you encounter the error, it'll first stop the execution of that, and it'll throw that error to the call which was calling function. It'll keep on evicting those from the call stack, and it'll have the trace back. If you have run a long program, then you might have seen in Python it shows some trace back. So this was the initial line where you got the error. So it works backwards. Let's suppose you got error in this function. It'll say I got error in this, which was basically called by this, which was called by this, which was called by main. Okay, it'll show you the whole basically calling stack, and it'll keep on evicting, because
Yeah.
getting error basically means it stops the execution. Yes.
Yes, so it finds the nearest catch block that it can find. Uh, is that right?
Not the, no, no, I'm not saying that error handling part. No, no,
Okay,
no.
okay.
I'm saying, let's say usually you haven't written any error handling. So you are writing something and there is an error in the code itself. I'm not writing you are doing that try catch blocks you are right though. We will also take the error handling separately. But right now what I'm saying is, if you encountered error in a function, you did some syntax error, semantic error, whatever error you did, okay, and you did not write that try catch. So what I'm telling you is, if that error is thrown now, so what will happen is, so it basically traces back. It will stop the execution of that function, and it will keep on evicting those things from the call stack. So once that try catch, you write those try catch, you basically make sure I know where the error is happening, because you usually when you have error handling, so it is supposed that you know that these errors will happen. That's why you write those error handling things.
Okay, so it does not return anything to the caller function, calling function.
Yeah, in error handling it does, but in here it does not. It'll just trace back there. It'll say, okay, there is something wrong in here, so this is where you have to fix it. Okay, in error handling probably you'll write custom errors. You'll say value error. You'll say something like, let's suppose some other errors. Okay, so whatever errors, there are a lot of types of errors. Let's say unbounded error. Okay, you will say that this is the error. It'll throw that message. It'll just a message, and that message will be of a certain type, and you know what type of error this is. Okay,
Okay, okay.
but calling stack should get emptied. It should not. It'll evict out those things from the calling. Otherwise, execution won't stop. So calling stack is the start where you basically started inserting these functions, pushing those functions. Because once you have had that error, it basically returns those things. Not returns some values, because values will be returned after the successful execution. But here, if it gives some errors, it'll throw them back, and it'll keep on evicting those things. What's called as stack frames. It will evict those stack frames so that it stops the execution of the program. Okay, so I'll just clean this VS Code. So here we have seen two functionalities of return. The first functionality was we return some simple values, and the second thing was we do early exit. So for early exit, I said if you have to do a certain thing, and after that the thing doesn't make sense. So I showed you the example also for there. And then you can also in Python you can do multiple return things. Okay, you can have multiple returns. So what I mean by multiple returns is, okay, this is the third thing. So this is third. So usually in other language you can just return probably one value, okay, in certain language. But here you can have multiple return things. Let's suppose you are doing something and you want to return a couple of things. Say you want to return two numbers. You want to return a lot of things. Maybe here what you can do is you can return a list. You can return a tuple. Okay, you can return a dictionary also. Okay, and you can return some multiple values. Let's suppose a comma b. But all in all, what will happen inside? So it will be converted into tuple. Okay, you can also return in functions. Okay, you can return these functions. So that is you can do with this return statement. You can also multiple return. So let's see how to do this multiple return in the code so that it becomes clear. Sometimes there is a need that you have to return multiple things. Okay, that's why Python has to choose, okay, should we give the functionality of this multiple return, and they have given it. So let us now create a new file probably, which we'll call as, I'll say code test2.py. Okay, then I'll also say this is my code file test2.py. So here I'll write Python test2.py. So it should show nothing. Yes. So now what I'll do is I'll write a code where it will return more than two things. Okay, so that's what I'm saying. What I can do is I can get a list of numbers, and I want to, from that I can just get maximum minimum. Let's take the example. Okay, parallelly you will probably solve some questions also. So let's suppose we have a list. So let's call that list li. So list will contain 2, 4, some numbers. I'll write something like this. This is a list. So my question now is, can you return my minimum and the maximum number? I have to return both of these numbers together. So what I can do is I can write a function. So definition of the function, so I can say min max. I can name it as min max. So I'll take this list as an input. So because now it's taking numbers as an input, the list. So what I can do is I can now write a code to find minimum. So I can say because there's a function in Python, minimum and maximum. So I can say minimum number is min of the list, whatever list it is, and then max is maximum of the list. So max number is equal to max of the list. Okay, usually this is a linear function, so I can return these two values, min max, not min max, min number comma max number. So this is what I can return two things. So what I can call is now min of this list, min max of this list. Let's call this list some lis now, so that you don't confuse it with this thing. So here what I can do is I can print these two things also. So parallel I'll print. So now if I run this python test.2, so here you saw that minimum number was -12 and maximum number was 123. So okay, because now I have returned two things add together. But you see that once I return these things like this, just comma separated list, internally what Python does is it converts them into tuples. So you can just see that by doing this type check. So you have a function called as type. So what you can do is you can write type of this. So it will show you that internally it's a tuple. So here class tuple is there. Okay. So if you want this to be as a list, so you can just add these things like this. So this will return it as a list. So if I just run this function, you can see that class list. So if I just remove the type, so you can see that this is now stored as a list. Okay, this is stored as a list, -12 and 123. You can also store a dictionary. So for dictionary, what you can do is you can just have these key value pairs. So let's suppose this is a key value pair. So if you now return this, you can see this is a dictionary. Okay, you can return the set also. By set I mean you can just have these curly braces. So you return them as set. So here this is a set. How to check the type? You have just write a function that's type. Just write this, save the program and go back here. So you see this is class set. So you can have multiple returns. So you can return a tuple, you can return as list, you can return a set, you can return a dictionary. Okay, and we'll see also how to return a function. You can return function. So this is multi-return. You cannot just return one value. Okay, you can return a lot of things. So here these values are homogeneous. By homogeneous I mean they were all numbers. Okay, but sometimes you can also return a string. So let's suppose I'll call it I'll say a string str. Just write str and string rather, it's better. So string can be hello. I also want to return this string. So what I do is I'll just write this string over here. Okay. So now what you can see is this should also. Okay, this is 1, 2, 3, -12 and hello. So we can also return heterogeneous element, not just homogeneous elements, whatever you want. Okay, and you can decide do you want to give them a dictionary, do you want to give them a list, do you want to, but usually what people do is they will give it as a tuple like this. Okay, so you can unpack these values also. You can unpack, because now the point is not to just print these values, to assign them to something. Let's suppose I assign them to a. So a is a variable. I assign this min and max to this value I called min max of this list lis. So I assign this to a. If I now print this a, if I do something with this a, I am doing printing. So print this a. Let's see what is the output. So here you saw that it's a tuple. Now you know that how to basically you can unpack these things. How can you unpack? Because you know that there are two values. You can write a comma b. Now what will happen is, because as this min max is returning two values, the first thing will get into a and the second thing will get into b. So I can just print these two things. So I am just unpacking the values. So here you see this -12 and 123 got printed, and now you have the access of a to b. You can do anything. You can do anything with these elements. You can just maybe add, subtract, whatever you want to do. I'm just showing a simplistic example so that you at least have a notion. If we return multi-statements, okay, if we return multiple things together, we can unpack them. So I write a comment here. This is unpacking. Okay, this is unpacking at the same time. Okay, we don't need to have a tuple and then index the tuple. You can do it like this. Okay, sometimes you might have seen in the large code bases they'll have multiple return statements and they only need one of them. So let's suppose I only need this max element for time being. So what I can do is I can write a and then I can write underscore over here. So underscore basically means I don't need it right now, but I need this a. But it will give me out because function is written in such a way, so it gives me everything at once. It gives me everything as an output. But I just need this one. I just need this a, so I can write underscore instead of this other value because I don't want to store it somewhere or I don't want to use it. I have no plans to use it. So you might also see this in the code. Okay, so this is the multi return. Yes, questions?
Yeah, miss, on the return, okay. Here
Yes,
we know
yes,
that it is going to be fixed one, okay. A
yes.
comma B. If we don't know like how many returns are going to happen
Mm-hmm.
in that scenario, how do we need to define
No,
that
no,
A
no.
comma?
But yes, yes. Good point. This is a good question. So by return, you mean you should know what to return. So you should know this is not like the thing. This is not like the arguments. This is not like arguments like you are sending the arguments. So by return, I mean you should know these things I want to return. Okay, I want to return this. Because as a caller, when you call something, what's the definition of function? The definition of function is that you should do certain things and you expect an output out of that. Okay, input you give something and output you expect something. Okay, and upfront you should know what should I return from the function. Is that clear? But it's a good question. Why I call it a good question? Because this is also like sometimes maybe I don't know how many numbers to return. Can I do a functionality of that? Okay, then you will have to probably implement things yourself. Okay, because as a designer of the language, they have to make design choices. So if you want to return variable things, so do you give the functionality to the user? So probably many of the languages have decided no, we should not give that. We should know what to return. Okay, we should not give this variable return because it does not probably make sense also in many scenarios. Maybe there will be a corner case where it will make sense. Okay, but for 99.9% of the cases it won't make sense. So it is better not to have the additional overhead while you return the variable number of returns. Okay, variable number of items basically. Okay, and maybe if you sometimes soon want to design a language, you can also have that feature. No problem in that. But it's a good question.
I'm not going to do.
I'm just saying, just putting a thought. Okay, I'll just pause for a. Yes, coming back. So last thing is you can return none. Return none basically means if you are return nothing, that run automatically by default none is returned. So return none. So by this I mean if you are not returning anything. So what will happen is if you assign that value to something, internally what Python does is it will return anything because I said exit will happen only if if something is returned. So if nothing is returned, so by default Python returns this none. Okay, because that's the reason I showed you this call stack. So I showed you this call stack in the initial few minutes. So I said, oh, this function will only get exit. Oops. So last thing is that return, what you can return is you can also return none. So I was discussing about this call stack. I said in the call stack, in order to evict a function, you should return something. But when you do not write a return statement, so by default, what Python does is it will return none. So just to demonstrate this, let's go to the code and see does it actually return none. So if you have seen it over here, so I have written some code. So let's suppose I'll write a function. So maybe I should save it. I should say code test3.py. And then let's write a function. I write a function definition func. Let's give it arguments a comma b. Okay, call something print. Let's say a comma b. I'll just print them. Okay, I'm not returning anything. I hope that this is visible. So what I'm doing is I'm not returning anything, and because I'm not writing return explicitly. So I'll just call this function with 1 comma 2. So if I now run this, so I'll run it Python test. This is 3.py. Yeah, I should save this first. So here you see nothing on the screen. Rather, you should print 1 to 1 comma 2 because I have printed something. But what if I assign this value? What if I assign a? So I'll assign this to a because I'm not returning anything. So what I said is by default it should return none. So if I print this a, the value of a should be none. Okay, none is one data type. We have seen that in our data type lectures. So you will see that this none is over here. Okay, because it's not returning by default. What Python does it return. I can also return none. I can return none. But if it's not written explicitly, Python will do it automatically. What is the rationale behind that? The rationale is that in order to exit a function, in order to get that function evicted from the call stack, you'll have to return something. Okay, when Python sees no return at the end of the function also, so it will return none. It will say I am returning none basically because all the statements were executed. So it is better to just write none. So I am returning nothing. Okay, none is the data type if you see that. Okay, so what have we done? Just to summarize these things, I said return has a couple of functionalities. So the first functionality that we saw is return values. So that's over here, written over here. So return values, then we can early exit. Okay, if there is a thing, if that condition is met and we want to early exit based on that, we also saw that. And then I said you can also use this return to multiple returns. You can return multiple things. You can return list, tuple, dictionary. You can return multiple values. You can even return functions. So at the last we said that you can also return none values. Okay, you can also do a lot of things. You can also do the error handling with this return. Okay, you can do error handling. So what I mean by error handling is you can raise errors. Let's suppose I'll just give you an example. Suppose you are a coder in some good company. So what happens that time is, and there you are reading a lot of files. You're reading a lot of files, and then you are doing something on that. You are doing something on the file. But sometimes what will happen is there will be a thing. Sometimes a file will not be found. There will be no file, no such file named as that. Okay, or there will be a thing where you have no permission to access that file, where you can deny the permission. Let's suppose you are writing something in which you are giving access to a file. Either open that file and do something with the contents of that file. Or the second scenario will be there will be no file found. Such file won't exist. And the third thing is you don't have permission to for that file. Okay, so in the two cases, in the first case you have to run these things. In the first case you have to run what I say is whatever contents are given to you, and you are basically getting those. You are getting the content of the file. You are doing whatever operation you want to on the file. Second scenario is file is not found, so you have to throw an error for that. Okay, but you don't want to terminate the program. You just want to throw the error. That is this error. Okay, and you want to show it on the screen. This is the error. And then what I am doing is that the third scenario can be permission is denied for the file, and you want to maybe have the rest of the execution. Okay, so that is where error handling comes in. So I think this question was asked by Fahad Asif. So they said, what does error handling do? So error handling, it stops the sudden termination of the program. So usually you do not anticipate the errors, and suddenly your program is executing, and then there is an error and it stops. So but what I mean by error handling is you write some things, and because you anticipate those errors, you thought upfront that these errors might occur. Okay, so in order to handle those errors, you said, okay, if this error occurred, just show it on this and move to the next. Okay, and then keep on executing the other things, but throw this error. Okay, and show this error, and you can deal. Maybe you can also write a program where you can just terminate the program, or you can also write where just throw this error and then keep on executing. Okay, so this return statement can also be used in error handling. So let's suppose you can create your errors, this file not found error, permission denied error, and then you can show it on the screen. Many times you might have seen when you write something, Python shows us the error message. It shows us the error. If we do some error, it shows syntax error and then some error. It shows when there is an unbound error, some name error. There are a lot of errors. So usually how people do it, they'll basically write a return statement. So if they write return, so it'll immediately stop that. So okay, let's write a simple program for read files. So what I'm telling you is this. So I'll go to the VS Code and we'll make a new file. Probably we'll write code, and then this is test4.py. Okay, so this may happen in real world. Maybe you are developing a website, you are maybe using Android for something, so there a user basically asks for a file. Okay, and then you have to handle that. So what I'm saying is, so let's suppose you'll write a function that is a read file. Definition, you'll say a function is read file. Okay, then you will take a file name as an input. Okay, you can take file name. Oops. You can take a file name as an input, and then what you can do is you can read this file. So what you are doing is you can use a try catch. We'll have those basically those try catch except blocks separately, but here I'll show you how to write the error handling code. So what I'm saying is you are saying user try this. Okay, and you should write try block. So I'm saying try. So what should you try? So you should try to open this file. You should try to open. So for that you can write code with open, and then you write this file name. So you'll write the permission. Let's suppose file name, this is the path usually. So file name, and then comma, in which mode do you want to open it? I want to open it in read mode. So we'll see all of these things. Do not worry about the syntax, but here I just wanted to show you because this is one possibility. Try opening the file. Okay, this makes sense to say. So here if you see that, what I'm saying is the scenario is like this. You are building a application where A user is asking to read a file, so you're writing a definition for the read file. You're writing a function, so you're writing definition read file, and then you're giving file name. Then you're saying, because you know the scenario. The scenario can be either you will open the file and you can read the contents of the file, or what you can do is, if let's suppose that file is not there, there is no such file found, so you should give file not found error. Okay, or if there is a case where the file is there but user is not allowed to access that file, you can say permission denied or something. So for that we'll also use return. So here what I have written a code in which I have written definition read lines, and then I'm trying to open the file. So I'm saying with open file name, and then in which mode I want to open it. Then I'll write it, open it as file. Then I'll do something. Okay, I'll say content, or this is content is equal to, and there is a function read line, so you can write file.read. So file.read, I'm reading this file. Do not get worried with the syntax, it's nothing but just trying to read the file. Okay, and then once I read the file, I want to return it. I want to return the contents of the file, whatever I wrote, whatever I got, I'll just contents of the file, I'll return this contents. Okay, this is what I'm trying to do. But I said there are two possible scenarios. One possible scenario is that the file will not be there. So what I can do is I can expect a thing. So I can say so this is try, and then I'll write accept. So accept, because there is a possibility of error. So accept. So what is the possibility of error? File may not be found. So you can create an error of your own. You can say file not found error. So here you say this, and then what you can do is you can also give a message with it. So you can say return file not found error. So return. You can say return error file not found. Return, and then you can say error, and maybe in a string you can just say error file not found. Oh, I should not write like this, file not found. Okay, and then maybe again there is one more thing, you can also write accept, because you also see that you can have permission error. So because you don't have enough permissions, so what you can say, you can have permission error. Okay, when will you throw this permission error is return. So you'll return this, oops. So you'll return, oops. So you'll return this error, and you will say permission denied. Okay, so this is what you can do is. So then I'll probably read a file. So if I read a file, I'll on purpose give it a wrong path so that it will show the error. So this is read file. On purpose I'm giving a file which, let's suppose example.txt is not in my list. Hopefully example.txt is not there. So if I run this, okay, so code test.py, have I, oh this is code, I should write Python test4.py. okay,
We should print that, I
yes,
think.
I think we should also print. So I made two errors. The first error was I just wrote code because it just opened the file, because it's returning the error. Okay, it's returning. So by return I mean I can store it somewhere. Okay, here it showed file not found because that file is not found. So let's suppose I'll make a file. I'll make a file example.txt. Example.txt. Okay, this is an example. I'll say this is the AIML class where the Bangalore authorities have cut our power line, something like this. Okay, now the file exists there. Okay, so if I do this, that content should be visible on the screen. Okay, now if I say Python test.4, so now you see this is AIML class, you can see it on the screen. Okay, and now if the permission is not there, so I can also create permission of the files, and then this error will be thrown. So this is how you can use the return statement. Is it clear? Any questions? Any questions on this? Any questions? So now we can call that, now we have function, we can do these things. So one important aspect is we can, this is another topics of functions, and because it's very important when you code, and you should know this. So this is called as scoping rules. Scoping rules. Okay, because I am teaching art of programming, not just Python. So first I'll tell you what scope means. Okay, and scope is a generic concept. It's not a concept that is only restricted to Python. Okay, and then we'll see how what are the rules of Python. So what Python does. So what scope basically means. So this scope is defined for these data types or maybe variables. is defined for variable. So scope, what it means is, it means the region of the program. So region of the program where you can access the data, or you can modify these variables. So region of the program, okay, where a variable can be accessed or modified. Okay, that begs a question that, oh, that variable will not be visible throughout the program. Okay, if we use some variable, and it probably will be visible only to a certain region of the program. So that region is called a scope. There is one more term called as lifetime. Okay, lifetime. So what does mean the lifetime? The scope is different. Lifetime means, okay, till what does this variable stay in the memory? Okay, can we access this memory? So what is the life of the variable? Does it, let's suppose if a variable is defined in the function, if function gets evicted, does it end there? So is the variable evicted also? Okay, that's called lifetime of the variable. So these are two different things, scope and lifetime. Scope means in the whole program, what's the region in which that variable is accessible, or maybe it can be modified. That is the scope. And I say lifetime basically means till what time is this variable living in the memory. Okay, is living, by living I mean that it stays in the memory, it is not evicted of the memory. That's the lifetime of a variable, and that is scope. And variables, can be data, it can be different things. Okay, so this is a scope, a general concept. Scope will be everywhere, scope will be in every language. Okay, and you have to have scoping rules. If you develop a language, maybe anytime soon in your lifetime, you'll have to decide what scope should I define. Okay, the Python developers were also faced with a similar question. Okay, now we have to scope, we have to have a scope of the variable. Why should we have the scope? The first advantage of scope that is very easy to find is because I don't want unnecessary variables everywhere. Okay, now if you tell me why is the scope needed, the first thing is this memory usage, efficient memory usage. So efficiently you want to use the memory. You don't want everything should be dumped on the memory, and maybe there are thousands of millions of variables and they are just residing in the memory and you are not doing anything about them. And the second thing is probably for the reason of maybe what I can say is maybe encapsulation, or you want to hide it. You want to hide some details, because if you want to hide those things, maybe we'll call it abstraction. You want to abstract out some details. Okay, what I mean by abstraction is your code may be a little very maybe it may be written in such a way so it looks tedious. So but the better way is, what you can do is, you don't give the external access. You say these are the variables which are with this function. Once you call this function, you are getting your work done. After that, you need to worry about these variables. Okay, and for the abstraction, we probably create those scoping rules. Okay, memory usage is one thing, and to hide those details, to do not show it, and otherwise it will look messy. It will probably scare people because of that many code. So it is better to have the variables which we just use locally and then destroy it locally there. Okay, so how I can tell you this is, it's like this. In your home, you probably will be doing internally a lot of stuff, but you want you want some things to get projected outside, like social media, Instagram. You put only your highlights of the life. Okay, you don't want to show whole life on the social media. So that's like that. You want to hide out the details. You want to abstract the details. Okay, that's why you have to define these scoping rules. Okay, what should be a scope of variable? So I define two terms. One is scope and one is lifetime. So scope is in what region is this variable accessible or can be modified, and lifetime is till what because the program has a life. If you run the program, it will start and it will terminate. Okay, in this cycle, till what at what time will this variable be destroyed? Okay, or will it remain throughout the program? This is the lifetime of a variable. Okay, here we are going to see the scope, and now we'll see what Python does. Okay, Python also has to define the scope. So there are some rules in Python. Okay, now we'll see what types of scope. The question should be, what types of scope does Python have? Types of scope. Because the natural question is, if there is a scope, if there should be some limited access, so what types of scope are there? So in Python there are four scopes, four types of scopes. The first type of scope is called global scope. Okay, we'll see all of these. I'll just enumerate the list first and then we'll take one by one. And the second thing is called as local scope. Okay, and this local global, it's also in other programming languages. Okay, most of these concepts will also are applicable on other programming languages, but here per se we are learning about Python, so we are just seeing them in the Pythonic world, and otherwise these concepts do apply on other language also. So there is one is called as global scope, then we have this local scope, then the third thing is which is called as enclosing scope. Enclosing scope. Then the fourth is called as inbuilt scope. Well, these are the four scopes. Okay, so what is the order now? So if this scope, assume that you know this scope, assume that you already know what is the meaning of these scopes. Okay, so now once a function, once a program is loaded, so it should follow some rule. There should be a precedence order. Okay, where should I look for this variable? Okay, is this variable in my local memory? Is this variable global? Is it in enclosing scope? Is it in built? Okay, so there is a hierarchy in that. How to find that? That's that rule is called as LEGB. Don't confuse it with LGBT. This is LEGB. Okay, it'll initially start with L, it'll see the local scope. The second is it'll see enclosing scope, then it'll see for global, and at the end it'll see for built-in scopes. Okay, and these I should write built-in scope rather in built, I'll write built-in scope. Okay, so this is nowhere related to LGBT. It is not related to this. Okay, but you can have memory mapping. LGBT, there is something LEGB. So by LEGB I mean you should first resolve local scope. You should find the variable locally. Then you should see if it is in enclosing, or if it is then in global, or if it is then in built-in. See, this is the what I can say rule or maybe hierarchy that is followed by Python. So now let's see one by one what these scopes are. Okay, let's start with the global scope probably. What is a global scope? Okay, scope has something to do with where you can modify or access the variable. Okay, so we'll see what a global scope means. So I'll just write some code in order to demonstrate that. Okay, if we define a variable and where can I access it, and we'll read it under the topic of global scope. Let's go back to the coding. So here now what I'm saying is the first thing is global scope. So what is the meaning of global scope? Global scope basically means the variable should be visible throughout the program. Okay, so wherever you define it. So this scope refers to variable defined at the top level of the module. Usually you define it at the top level. Okay, and it is outside any function or any class. Okay, whatever function you define, whatever class you define, whatever modules you define, you just define at the top. Okay, and this variable basically is the global variable. Okay, that is the scope of that variable, and scope is it is visible throughout the program. So now let me show you in the code. So what I mean by that is, let's suppose I'm writing different functions. I'm writing a function. Let's call this a definition some function. So I'm taking some value as an input. Let's call this an input inp. Okay, let's do I'm doing something with the input. I'm printing that input. I'm printing this inp, whatever input I'm getting. This is my function. Okay, so if I am doing something, let's suppose this input can be a number. Okay, so I have a number which I'm defining outside the top module. So what I'm doing is I'm defining a variable, call it number. Okay, and then I'm saying 5. So you see I'm not defining it inside the function, I'm defining it outside the function. So after that what I'm doing is I'm also printing this number, printing num over here. Okay, now if you see this can be printed over here. I can print it outside this function also. So if you see I am printing this now outside. Okay, let's call this function fun. So I'm calling this function with some input hello, something like this, very simplest example. But what here you can see is, so in this I want to access this variable in the within the function, and I want to also access this variable outside the function. So this is, so let's call this inside the function. So I'll have an additional print statement which will tell me this is inside the function. Inside the function, pretty bad. Okay, this is inside the function, and once I go outside the function, this is outside the function. Okay, so this is outside and inside. I'm defining this way. So once I get inside the function, it will show inside the function, and once I get out of the function, it will show outside the function. So what I'm doing is I am just, this is the variable. This is the variable under consideration. This num is the variable under consideration. So what I'm doing is I'll just run this program. I'll say python test.5. Python test5.py. So what you can see is you say inside the function, and this hello was printed, and this number 5 we were able to access this inside the function because number 5 was here outside the function, and because we were outside the function, and then this number was also printed outside the function. This is what is called as global scope. So what I meant by global scope is the variable is visible throughout the file or throughout the program. So what a program you are writing. Okay, so this scope is basically where variables are defined at the top level outside any of these functions or classes. So that's called as global scope. Okay, and then we'll see what is the local scope. Then we'll see what a local scope is. Okay, let's go to what is a local scope. So local scope. So it basically means global by definition means something which is like at the globe. At the globe, I mean which is visible everywhere. Okay, by local I mean it should be visible to something. Okay, sometimes we say this is local food. Local food basically means this is what is accessible in neighborhood. Okay, and we define the neighborhood. That's what I'm saying. So there is one scope is which we call as global scope, which is visible throughout. Okay, maybe eating sugar is global. Okay, then probably having Kashmiri Wazwan is local to Kashmir. Okay, that is not global. Okay, maybe you can replicate these things and then we'll see that. So local scope is where you basically see something is local, something is accessible locally. Okay, you will see that. So let me take an example to demonstrate this. So let's again make a and these things are defined within the block itself. Okay, so let's call it a local scope. So going back to the coding window to show you that. Okay, this is global scope and I'll just comment out this code. Okay, now I'll define something local. Let's suppose I am defining a function. Define, we'll say food. Okay, so what I mean by I'll say I'll take anything. Maybe I'll not take input either. Okay, so I'll say let's suppose item. Item name is Kashmiri Wazwan. Let's suppose. Okay, I'll probably write here food of Kashmir to make it. Okay, this item now what I create it is local. So what I'll do is I'll just print this out. I'll say print inside the function. Inside. Oops. Inside the function. So what I'm doing is I'm printing this item. Maybe print this item. So I should not even write. I should write this item underscore because I fear that this will be some function. So it's better to write item underscore. Item underscore. And then what I'm saying is I'm calling this function. I am saying food of Kashmir and I am calling this function over here. Okay, and then I'm saying outside, print outside the function. Okay, and this then I'm saying print. What I'll write is I'll write item. Okay, so this is some sort of global thing. So here what I'm saying is something hash global. So what I was doing, oh, terrible spellings. So global. So here if you see this, let's suppose this here over here is value of Kashmir. Okay, once you enter the value of Kashmir, you have this Kashmiri Wazwan. But once you come out of that valley, so you should have no more access to the Wazwan, at least authentic Wazwan. So let's suppose if I run this file now, if I run this Python test.5, you can see we got an error. Because now there will be two types of errors. So you see this error, this is called as name error. So why is this name error? Because name error is because this is nowhere defined, because it looks that outside is not visible. Let's suppose I'll just comment out this code to show you first internally it's visible. So Python this, you can see inside the function, Kashmiri Wazwan is there and we're outside the function. We are done. Okay, we're outside the function. Once we go outside the function, if I now try to bring the Wazwan, if I'm saying, okay, now print me the item that was in Kashmir. Okay, sometimes people go to Kashmir and it was one there, and then once they return home, they're saying that, okay, I am yearning that food again. I want to eat that. So if they again call this print item, so now it will throw an error. What it will say is you are no longer in Kashmir. Basically, you are there's a name error. Okay, so name error is name item is not defined. So it is saying, oh, the item you are referring to, I do not even know the meaning of that, know the name of that item. Okay, so that's why it's showing this name error. You'll see two errors. You'll see one is name error, and that is unbounded variable error. So unbounded is where it won't be able to, and both of these will be somewhat like with those things, with the scope of the variables. Okay, so how many of you understood this local scope? So local scope is defined within a function. You have a question? Yes, somebody has a question. I think nobody has a question. And anyone? Any questions? Any questions still here? Okay, this is what is called as a local scope. Okay, then we saw two scopes. We saw global scope and then we saw local scope. I think there is a question. Yes.
I think this is a bit irrelevant, but I would still like to ask. So, is there a distinction in computer memory as well between these variables, or in memory they are just homogeneous
No.
across?
So in memory they are defined differently. So when you write a program, so these global things are probably kept in separate. I would love to someday discuss memory thing with you. How is this memory? When a program is called, there is that frame structure. How is that? It has 4 parts. It has code segment. It has that that variable memories. It has the stack segment also, and these global variables are defined with the code itself. Okay, they die once the whole program is executed, and local is within that function stack. When you call that, and that stack that contains all the, that's called dynamic allocation. So once you create that memory, and those variables which were with the parameters, they get created with the function call, and once the function is evicted, and these variables are also squashed off. Okay, look, that's why you cannot access it. That's what happened here. Once you executed that function, it basically got squashed. That's why it said name error. It says it's nowhere there. I looked at it. So how it checks? It checked in the local scope, but it was not found in local. Then it checked for global scope. It was not in the global also. It said this item is not defined as a name error. I hope I gave a simplistic answer, and but I would love to take one session on this, how this computer memory is basically divided, and when program gets loaded, what are the different parts of the memory, and we'll also see that in action. Okay, probably that time we'll code in C or C++. It's better to show it with that.
Yes. Yes. Yeah. Because in case of threading, because two functions can be running at the same time, so
Yes,
they.
yes, yes.
Yes. Okay.
So it's better we'll show it in C++ because it gives a lot of access to the low level code also. So here in Python, we can do it in Python also. But the problem is you have to unroll a lot of stuff. You have to unroll, and then get into fine detail. So it is better. So we'll have just that one lecture for how this memory gets allocated. How is program executed. Okay, and we'll have a simplistic view because otherwise we'll need probably a whole series of lectures on this, how program gets executed, what is happening underneath the computer. But for how this function calls are happening, actually I think I gave you an overview of like some couple of minutes in the previous lecture also. Once function is called, what are the steps that happen, but we'll see them in the action soon. Okay. Okay. So each time when you basically execute a function, a local namespace is created. Okay, so what is called as local namespace? Local namespace gets created. So when you call this function, okay, this namespace is basically an environment. It is some sort of environment. It contains the names, the values, and these function parameters. Okay, and these variables that are assigned inside the function body. Okay, the binding of these names basically is known in advance. Okay, when the function is defined. Okay, and these names are assigned within the body and are bound to these local environment. Okay, so all the other names which are not assigned, okay, they're not assigned, but they're just used some but not assigned in the function. They're called as free variables. We have free variables in the body, so we define something as a variable, but we don't assign it a value. We call them as free variables. So what I said is, when a function is executed, a local namespace gets created. Okay, this namespace is actually some sort of environment. It contains whatever names are there, whatever values of the function, whatever parameters are there. Okay, and there are these assigned variables which are called bound variables. Okay, this is just a created name. So bounded variables are variables where you define the variable and you bound them to some values. Okay. Then there are these free variables where you write these variables and you did not bind them to some. These are free variables. Okay. And when will they be used? When it's dynamic. Okay. So now there will be two errors which I was talking about. Okay. One type of error which occurs during the execution of function. So that's when it sees a free variable with undefined name. Okay. So it is called that thing probably will be called. Let's suppose there will be two. I'll write the errors first. So one is name error. Name error. So there will be two types of errors that you will see, and this is because of the scope. That will happen because of this global and local scope. So one is name error, and there is called as unbound local error. Unbounded local error. So these are two errors that you will frequently found because of these scope rules. So what will happen is, so you'll have this name error exception. So how is this name happening? So when undefined name or free variable in a global environment results in this name error. Okay. So let's first look at this. Maybe we'll look at this unbound local, and then we'll look at the name error also. Okay. Let's suppose I'll write a function, and then on a certain condition I'll make it on purpose. I'll fail the code on purpose. So if you see, so let us clean this code. Let's save this, and maybe add a comment out the whole part, and then we'll go here. We'll clean this terminal also. So what I'm writing is, I'll write a function. Let's call it define a function. Okay, func. I have defined fun function. So I'll take in variable x. So if this x is greater than a certain value, so I'll maybe do something. So what I'll do is, I'll say, let's suppose if x is greater than 2, I'll create another variable which is y. So here I missed colon. So I'll create another variable which is y and call this y as, let's suppose, 10. That is the problem with the indentation. It has to be correct. Okay, then what I'll say is I'll say return x plus y. So you see the problem in there. So this code has one problem. So what the problem is that if I, let's suppose, call this. So if I call this function with a value which is greater than 2, I'll call it with 3. Okay, this function will get perfectly executed. Okay, what it'll do is it'll do x plus y, and the x plus y is, let's suppose, 3. So 3 plus y is, that is 13. It should print 13. So I'll just print this value. Print this function. Okay, I'll save it and I'll say Python test5.py. So if you see 13 got printed. Okay, now what if I give a value which is less than 2? So I'll give probably one value. Okay, less than or equal to 2. So if I give this value 1, so what I say, this will show me unbounded local error. So if I just run this, you saw this unbounded local error. Cannot access local variable y where it is not associated, because this was a free variable. So because it was getting bounded once we went in the if condition, but we never met the if condition, but this condition was never true. So we never reached here. So it is that's why it is showing this unbound local error. So it's showing cannot access the local area y where it's not associated with the value, because we have given no associated value, because it was there somewhere in the memory, but I cannot figure out the value because it's unbound to it's not bounded to anything. It's sort of free. So this is one of the type of error that you will get. Are you clear with this? I hope that this should be clear. So this is one type of the error. So where you get sometimes you'll return the value, and sometimes based on that condition you will have that error. Okay. Also you will have unbound error like this. Let's suppose I'll create same function. Maybe I'll define def function. And what I'm doing is I am adding plus is equal 1 to this is a variable. Let's suppose this n is a variable. So if I am adding it to somewhere, but it is not previously defined anywhere. Okay, so I'm assuming it is there. So again, it should show the same error. So if I call this function fun, if I call this fun, so if I now run this again, so here you can see this. Again, the unbounded error is there. Maybe you're defining n, because Python is a dynamically typed language. Okay, when you see n, it creates n value, but it is not bound to already value. So it is not bound to the value at the initialization, and I am suddenly adding 1 to it. That is seeing there is no value. It's not bound to anyone. So it is better that I'll throw this error. I'll throw this unbound local error. Okay. So these are the two examples which shows you when this unbound local error happens. Okay. And then let's suppose we'll do one more thing. Maybe we'll do some trickery so that you get this idea concrete. Let's suppose I'll write x is equal 10. Okay. I'll say def a function. Okay. So this is a function. So what I'm doing is, so within this function, I'm, let's suppose, printing this value. I'm printing the value of x, and I'm calling this function. Okay. So what should be the output of this code? So what should be the output of this code snippet? Anyone? Output of this code should be, don't run it. Tell me, huh? Because we have seen this. I think we saw it just before some time. Because this is a global variable, and now what it will do is this print will look for the local value, but if it's not locally, it will see in the global scope. Now x has global scope, so if we run it, you can clearly see the value was 10. Okay, there is no problem with this when I run it. So let's suppose what I do is I'll do one more thing. So I'll just define x now. I'll define this x locally, but I'll define it after I print the value. So I'll say x is equal 14. Okay, what do you think? What should get printed? Will 14 get printed, 13, 10 get printed? What should get printed on the screen?
I think it will be still 10.
It will be still 10. How many of you agree with Mahmood? Why it is still 10? What's the rationale behind that? Because we are initializing the value after the things get printed. Okay, let's run it. Okay, and let's run it and give it a shock. Okay, I think I have not saved it. I'll save it, and you see this. It is giving me error again, unbound local error. Why is it so? Because when prints x, I told you about the rule. I told you rule. It looks for the local scope. It will see if that x is locally defined somewhere. Yeah, it found it locally defined. It found that x is locally defined, but it did not assign the value, because before this print was executed, and after that this value was assigned, but x was still there. That's when the function was called. I told you when function is called, this namespace is getting created. Okay, namespace has those variable names, but this binding will happen dynamically. Okay, when it looked for the local scope, it found x there. Okay, but that x was not bound the value because the binding of the values happened after this call, after this print x. That's why it showed this unbound local error. How many of you got this point? Why is it showing this unbound local error? And you got something more out of this. Why is it showing this error? How many of you got this? Okay, the point is because I told you the rule, there is a hierarchy. So it will first check in the local scope, and in the local, it found x there. The x was there. Okay, and but the value was not bound to it because the binding of the value happened after this call. Okay, that's why it throwed the error. Okay, I hope this was clear. Okay, now what we can do is so we can basically modify it also. So we can write maybe global of x or something. So we can write global of x and then probably do it. It will modify that, but we don't want to do that right now. Okay, so this is one of the error that's called unbound local error. So the second type of error I said is that's called as name error. Okay, so name error will happen when the name is no more there. Let's suppose this print, this x is not here and this x is not here. If I am calling this function, the name error will happen. Okay, because this name is not there anymore. So if I'm writing Python test.py, so you saw this name x error because when I'm looking at the scope, this variable is not defined at all. I did not see this variable anywhere, so it is showing me this name error. So how many of you got some clarity about these two errors, unbounded local error and the name error? Okay, I hope that you got some clarity about these two things. And why do they happen? There is a lot more things to learn about these things. So let's suppose I'll just take one more example. Okay, but for that I need a concept nested functions. Okay, maybe we'll take it in another class. We'll take nest functions first, then we'll take this, and we'll learn the concept of microservices there, how the Netflix runs their things, and what are these microservices on an event. What things do happen. Okay, so I'll stop the recording here. If you have any questions, I'm ready to take that. I am stopping the recording.